So, good evening, everyone, and maybe also afternoon or morning, depending on where you're joining from. I know I can see some familiar faces who are joining from really, early AM, like it's past midnight for them. I'm going to try to make it worth your time. So, my name is Michael Olafusi, and I'm going to be doing this session. So, I'm already here anyway. So, intro, I'm going to cut it down. This is what we are here for. So, I'm going to make sure that I go straight into the LangChain and LangGraph. Towards the end, we'll do Q&A. We might spill over the hour. Like I'm going to be here more than the duration so that if you have questions, I'm going to answer. And towards the end, I will enable chat and all of that so that we can speak. I will enable audio. You can unmute. You can also put in chat, but we don't want to do that right now. Okay. And in for next month, we have another session that's going to be on data lake, data warehouse, and we've got the founder of Lucid Data Hub is going to be sharing with us. So that's you can always find out on our community page. And this is me. I have been in the consulting space since 2014 when I resigned my job to go fully into consulting, and it's because I like the ability to learn something. This AI agent stuff, it's interesting. I learned it in December. I started learning it in December fully because I'm part of a community where we wanted to automate something, and it seemed like AI agent was the right way to go about automating it. And see how quickly between that time and now, I'm beginning to do sessions. I've built a couple of AI agents, since then, and I have a busy work life too. So it's that's the beauty of consulting. Consulting, you are always wanting to quickly go to market with your knowledge. So, all right. I'm just saying that that's why I love consulting, and I've written books. Let's forget that one. Let's go straight into what we're here for. So, LangGraph is a framework. Like it's if you look at this properly, I'm going to say at the core of it, if I was to draw this all over, it's just that I'm not good at drawing and I like some of what this is. At the core of it all is LangChain. So LangChain has been, I think, so that I don't say on record something that I know is not accurate. So LangChain has been around longer than LangGraph. And LangChain is like a framework to make it easy for you to build AI agents. So you don't have to code everything from scratch. So imagine you're using pandas. Think of pandas like a framework to help you work with data frame and data that you're going to extract from common data sources. So that's what LangChain also does. If you use LangChain, you will not have to code everything from scratch. So I'm going to show you an example where I'm using LangChain, and because I'm using LangChain, I'm able to switch between different LLMs. So what I mean different LLMs, I've got these on-prem local LLMs. These are on my computer. So I've got Gemma is the open source LLM from Google. Phi is Microsoft open source. Mistra is from the same company called Mistra. Gima, DeepSeek, we all have heard about DeepSeek and DeepSeek. If I even type right now, I've got also Llama 3 by Meta. I can switch, using the same code. If I go here to my code base, which means I can write my program, I can write the agent and whatever I'm building within the AI space, within the Gen AI space. I can write it and switch LLM at any point, even to a future LLM, an LLM that is not yet existing now. And I don't have to refactor all of my code. Why? Because I am leveraging a framework that they've been able to, do all of that underneath. So because I'm using LangChain, and then I'm able to just switch from any LLM to another that I want. So that's one of the advantages, which we will again go through. That's why LangChain is, to me, I think is the most robust framework right now. And while I was at a Microsoft conference, Microsoft actually is working with them. If you go on the developer, I'll share resources maybe after so that I focus more on the demo. So I found out that all the major players already handshakes with LangChain. They already make their tools available as integrations, as libraries within LangChain ecosystem. So I'm like, if I'm going to pick something to learn, and I'm doing this part time. I'm doing this on my weekend after work. Then I want to learn the thing that is at the forefront of it all, right? So that's why I picked LangChain. Then LangGraph is now maybe eventually to be a low code, but I wouldn't say it's a low code right now, but it's a higher level of abstraction. So it allows me to do a lot more, almost like what MCP. I don't know if you've heard of MCP. MCP is model context protocol that is now made popular by Anthropic. I think they started it, but now everybody's beginning to converge as that's going to be what they want to align with. So um, let me not throw in things that not everybody is familiar with, but I'm just saying everybody's beginning to agree that we should have a framework to make it easy for all the LLMs to interact, and then you can build things and expect consistent results, even if you are using a different LLM, if you are swapping out the actual foundational LLM. So that's my own way of explaining LangChain and LangGraph. LangChain is a base framework, let me call it that way. And LangGraph is a higher level abstraction that makes it such that the thing I will have built with LangChain, in fact, this way, the agent I will have built in my pure Python knowledge that will take me 1 week. In LangChain, maybe it will take me 2 days, but with LangGraph, it will take me 30 minutes. That's how, and I'm not exaggerating. And I'm saying this as someone who is all new, less than a year in this space. So it means what will have taken most of us of this kind of a beginner intermediate knowledge 2 weeks to build with just pure Python knowledge. With LangChain, you build it in 2 days. With LangGraph, maybe in 30 minutes. Okay, so I'm going to talk more about the concept of graph, nodes, edges. So I'm going to just say the takeaway from this slide, LangChain is the foundational framework. LangGraph is on top of, well, it can also work on top of other things, but in this context of what we're doing, we'll say it's an abstraction, higher level abstraction on top of LangChain. And then I'll give you this slide. So the other ones, don't worry, you'll get it. So I don't confuse us. So there are many different kinds of AI architecture. When you're building an AI agent, you have to think about it. Do you want a chain? Do you want, like RPAs, robotic process automation, where you say, okay, if a file gets dumped into a particular storage environment, you want something to pick it and then maybe trigger something to work on it and then push the data. So those things are like step by step. You know what your step one is, you move to step two to whatever. There's never going to be a feedback loop. You wouldn't have a step where, depending on what happens in that step, you will decide whether you want to go backwards or you will always keep heading in one direction. So that's a chain. Is the easiest one. When you are chatting with the chat version of the LLMs, you go to ChatGPT or any of all the major LLM providers create a chat interface. What you're doing mostly is almost like a chain one. You ask it the question, it replies you, and very little complex thing is happening. Okay, then there's the router agent. So the router agent is the one where you can see it can branch out depending on the context and the goal. It knows that, okay, I have multiple paths that I can go through, and then I'll choose one path over another at a point in time. So some RPAs can still do this. You could have a logic that says, oh, if this is there in this context, take this path. If something else is in the context, take the other path, or if something is missing, you could have like a basic, you know, two like a Boolean outcome based kind of logic that makes it goes in one of the two parts. So this is not really the big reason why, at least if you are building agents, you want to go beyond these two levels, right? So you want to go to a reasoning agent, and we're going to build a reasoning agent in this session. So a reasoning agent is the one that you've given capabilities, like tools. So think about what you already do with ChatGPT. If you are like me and you've used it, you've asked it question, and you are amazed. You see how well it's able to provide you answer in a short time, and the body of knowledge it seems to be aware of. And so now imagine that instead of you just chatting with it and getting an answer, you have it hooked up to your calendar. And so you ask it, okay, I want to go on a, Easter holiday weekend. I want to go on a 2 days trip. Yeah, it should check for stuff and deals. But when you now say you like something, what does it do? It goes and book it into your calendar because you've given it the ability, you've given it a tool, you've given it we call it a tool anyway. Yeah. So that's what it means. You've given it something beyond just reasoning and giving you back answer in a text or like something that you understand, but taking an action on a very different thing that you have to give it access to your own personal access. It's not going to just have the ability to do that without it getting something personal from you, maybe your login details or some kind of API connection. So whenever you give the LLM is the reasoning agent in the brain in this whole agent stuff. You give it tools and you let it be able to decide what tool to use, and then finally come back to you with an answer, you know, which is the end or end the session. Then that's the reasoning agent. So we're going to build that's like there are many complex versions of it, but you can say all the really, intelligent AI agents or really impactful use ones, they are reasoning agents. They do a lot of reasoning and choosing what tools to use and doing things for you rather than just chatting back to you. All right, so that's it, the theory part. Yeah. So I'm going to exit this slide and then I'm going to I have two demos. So I'm going to start with the first one. And for those who are just joining, I might be wondering, why is it that you cannot chat and why is it that you cannot access the audio? It's because somebody was trying to hijack it. So I will enable it at the end for Q&A. Right, so this is my slides. So we're going to build all of this from scratch, right? So I don't want to keep talking. I know most of you are tech, and if you're not tech, you rather see things and play the video after this session is being recorded. So I have two demos. Demo one is this. Like, we build an agent, you ask it a question, it answers, okay? Demo two is this reasoning agent. So I'm building a daycare research agent. We're going to build it together. And I give it data. Well, anyway, let's do it rather than talk through it. So let's start with demo one. And maybe I'll make it possible for us to practice along eventually, or like give you access to what we build. So I'm going to go to GitHub, GitHub desktop. Okay. And I'm going to create I can see someone's hand is up, unfortunately. I'm careful to turn on the chat feature. So please bear with me. Towards the end, I'll turn it on. Let's exhaust the patience of those who are here to hijack the session. So I'm going to create a new repository for this. I will call it live demo AI agents. And then I will give us access to these at the end. Let's ignore those ones. So readme, MIT, git ignore. Anyway, I'm going to just pick Python. Okay. So I'll create the repository. I'll publish the repository. So when I hit publish, I will not make it private so that you can access it. I'll give us the link. If you go to I could show you. Again, I just want us to focus more on. If you go to my GitHub account or type my name in GitHub, you should see it. So this is it. You will be able to access it. Right now it's empty because we're just starting, right? Okay. So I'll build straight into the main branch. So I'm not going to create another branch. It's a throwaway repo anyway. I'm not going to delete it. But all right. So let's see. I'm going to show in Explorer. Okay. So this is it. I don't want you to see my my environment files, where my passwords are. So what I'm going to do is I already have the environment file that I need in the one that I've built. So I'm going to copy it and put it here. Okay, so that I don't end up opening it for you guys to see, and and then I run out of credit, like you go use it and I get billed crazy amount. So one more thing I need, right? The requirements, so that I can show you. So this, to make it fast, I'm going to just also grab this and paste it there. So I'll grab these and then also inputs. So we'll even do another one from scratch, but like I have the daycares I want to research and all of that. So we'll do that together. So let's grab requirements. Requirement is what I'm going to need to rebuild the virtual environment. So I'm just going to put that here. All right. Then, so we need the research input file for one of the, let me show you what I mean. So I'm going to put one of the agents will be the daycare agent. So I'm going to just put that, okay, these are the daycares I want to research. Okay. And what I'm interested in is I want to know, I want the AI agent to take this daycare, take this information that I've given it, and then go online, research about it, give me the summary of reviews about that daycare, get me info about the price. Are they enrolled in the subsidy stuff, and give me general summary, right? And how did I get all these daycare data? Let's add one more so that you can see that it's not a difficult thing. Daycares in Toronto. Okay, so this is, let's pick this one. I don't think I have this already. So pride, right path, I can add it. Right path, search center. Already, since I have the website, right? And grab the website. And then it's in Toronto, Canada. That's all. Okay. And if you go, there's a website where I could even, that's what I'm planning to do. When I'm done, like just go here and grab all of them from here. There's a to Z of all of, and so getting it is not too difficult. You could even build an agent or something to scrape the data. So this is not the hard part, but I'm just showing you, this is as practical as any people who have little children to put in daycare will find. So I'm going to close this now that you know what's in there. So that's the input file. Imagine I've got 200 daycares and I want it to research it for me. So now that that is done, we can go to this is the folder. So I'm going to go to, I use Corso. Corso. Like, people correct me when I say Corso, they don't know, and then I say Corso. Oh, the new, AI agent powered IDE. So in case you've not used Corso before, it's like Visual Studio Code. It's actually a fork of Visual Studio Code. Then they added AI agents on top to make it easy to Copilot. Like it's the next level to Copilot. So I'm going to tell it I want to open a project, which obviously is that one we just created now. So I'm going to go here. I call the folder, this is it. And then this is live demo. So I pick the folder. All right, so let's start into. So I'm going to let's put this in full screen mode because this is the main window we're going to be using. So I'm going to add a new terminal, and then we're going to create an environment. So vnv.vn. So create a virtual environment, and see. Okay, so that is done. I'm going to switch into that environment, right? So scripts, activate. If you're using Mac, you have to use the source and then space the .vnv/bin/activate. So, okay, and I'm in here, so I'm going to tell it to pip install all the stuff that I need, which are already in the requirement folder. Requirements. And so that for if anybody is trying to practice along, I can commit this, initial setup. Sync it, which means it's going to show up here. So which means if I refresh this, can you see that it's showing up here already? So let's go on. And I go back here. So what did we finish? Okay, this is still working. And there is one, even if Visual Studio shows, this is actually Visual Studio Code. So even if this shows you that, switch into the virtual environment, I recommend that you still do the Control-Shift-P, pick the interpreter and pick exactly the interpreter you want because I'm going to use the debugger in here. So I need to be sure that it's picking the correct environment. When it's done, it should show up somewhere here too. But because I think you're still setting this up. So let's start with the demo one. So I'm going to come here and say demo one. Let me just say simple AI agent. .py. Okay, so this is an opportunity for me to walk you through, what we need to even use an AI agent. Okay, so first of all is I didn't show you this, but let's see if I can copy what an example environment is so that you know what you need to get. Example env. Okay, so this is what you need. Hope I'm not putting any genuine one there. Otherwise, I'm gonna have to remember to disable it. So these are the keys that are in my home that I'm not going to show you because they are my account keys. So it means I need to load them, right? So I need to do, so it's faster for me to copy and paste than to type. And because we have a lot to do, okay? So this will load the environment, and also somewhere after I'm going to do load.dev to get all those things, my keys, my variables from that, okay? So that I need. Then what other things do I need? So I'm going to show you, we're using LangChain. So for sure, if I know that I'm going to use, so in my case, I'm going to use, show you, so let's just minimize this. So I have a local setup. I have Ollama on my PC. So I have Ollama, see? I have Ollama set up on my computer. So via Ollama, right? Let me just show you how it works. So So I have Ollama and I have some local LMMs. So I've got Llama 3, all these that you see anyway. Anyone I want to run, right? All I have to do is do Ollama run, and I could do Llama 3 here. And what will happen is yeah. So it's running now. I can ask it a question. I can say, tell me a joke. And it will reply. What do you call a fake noodle? Anyway, so it is working, but that's not why I am loading it. I'm loading it so that I can use it here, right? So for me to use it, instead of me now coding everything from scratch, thinking of how to interact with that particular Ollama LLM, I leverage LangChain. So I'm saying from an existing LangChain library, import chat Ollama. So that way I can chat with it. So means I can now programmatically use it. So all I will just say is I'm going to define an LLM and say this is equal to chat Olama, and that the model is the one I loaded. Which did I load? That's this one. So let's just grab this, and then I put this here. Okay, and then I can ask it a question here. So this brings us to gradually how we use LangChain, and in this case, I'm beginning to now go into LangGraph itself. So there are some important concepts about LangChain and LangGraph. Okay, let's see if I can bring them. I'm going to bring them as notes so that I will read them to you. Okay. So for LangGraph, there's a concept of states, node, and edges. If you remember the slide, node, edges, node, then there's states. Okay. So great. State is the entire session, and so I have to define the state. So that's why I'm explaining this. So I'm going to define a state. A state can be, like I wrote here, can be a type dictionary, pedantic model, data class. So states are what the data I want to hold that's going to be consistently available throughout the session. Session is the entire end-to-end of the agent operation at an instance. Okay. So to make things faster, I'm going to say this. So I'm going to create a class, call it agent states, okay, and then say it's a typed dictionary, typed dic. Now I'm not getting IntelliSense. It's telling me I don't have these, so it means I need to import it. So it's from typing extension. So let's bring it in, typing extension. How many more minutes? So I'm going to be faster so that we can go more to the real one we want to work on. Okay. So instead of me typing everything else, I'll just paste what I want to use. Once you get this part, hopefully the more complex one we want to do will stick, even though I won't do as much line by line coding. That one I will try to talk less and walk you through the code more. So I've created this state. State is important, which means I need to create nodes too, right? And I will tell us about edges. Okay, so a node is usually set up as a function. So I have to say create a function for this agent is going to have one node, okay, which you will see. It's just going to be start. There's only start and end. So anything in between start and end, most of the times will be nodes anyway. So I'm going to create a node where I'm just asking questions, right? So I'm going to copy a function that is nobody can say is complex and just paste it here and say, okay. So I'm going to call it ask question and tell it that it should be aware. So I am making it a subclass of, no, I am passing into it the states so that it's aware of all that we have in the states. Okay. All right. So clear. And then I want to see what is happening on the terminal. So I'm going to use print. But if you're having this in programming, you might want to use log. I want to use a login library. So I'm going to just print the response. Okay. I think I should put that within the function itself. Okay. So, and one more thing. So our function must also return back. It must return back updates to the states, like something that is contained within the states. Well, it could return back something else too, but if I'm going to want to use things that are relevant to the state, then I return things that are appropriately marked to the states. Okay. And I'll tell us about system message and other things later on. But let's go on. So now we have two of the main things. We have a state, we have a node. So this is the state. We have one node in this case. A node is always most of the time is a function. So a node, then we're going to create edge. Edge is the easiest to create. We'll create it within our graph. All right, so we're going to now create the graph, the dimension graph here. Well, graph, graph itself is a graph. So because I could, following Python recommended way of doing things, I'll probably want to say, okay, I want to put everything in, if I want to put everything in a main, let me just copy it from somewhere nearby. So I want to put everything in a main to make it just best practice of programming, and allows you to do unit tests, as you build things more. And it's just the best, a good way to keep doing things, even if in this case, it makes no use. It's a throwaway practice. I'm not going to use this afterwards. Okay, so we always start with the graph builder. So I'm going to initialize a graph and say, in fact, let me just copy exactly what I need and paste and modify a bit of it. So we initialize a graph, and now it does not recognize what state graph is. It means I need to bring in the library that is for that. So you can see how gradually we are bringing in what we need. And when I go here, you will see that we brought in LangChain and LangGraph. And that's why this webinar is on LangChain and LangGraph. So now we have brought in LangGraph itself. And LangGraph has got states and start and end and some other things. But these are the three things we're going to use. So now I wouldn't have an error with this part. And then this is the state that will go through, that we run throughout the session of the AI agent. So I need to just put in the state name properly, which is agent state in our case. Right. So move on. And I'm going to build the graph. So I'm looking at time. So I don't want to spend so much time on this one. I want to do more on put more time on the daycare research agent. So I'm going to copy my entire code line for this. Okay. So this was where we stopped, right? Now I will add nodes. In this case, I said we're going to use just one node. So that's what I'm doing. I'm putting only one node. If I needed to add two nodes, or the next one we'll do, I think we will have two nodes. So you'll see. So I had the node. The node will always be, let me just write this again. You know what? I'm sure you understood up to this point. Let's do one line by line code. So at least you get the steps. I had the node. So this is the node I want to add. And this is how we had node. This part is compulsory like this. This is just the way you start it, right? So you give your node a name. I can call it anything I want. So in this case, I want to call it ask question or question, whatever. Just give it a name and move on. And then what function is going to be, this node is corresponding to what function, and this is it. But it doesn't mean the name has to be the same, This is just a label for you that you will see when we build the graph. We're going to build the graph, so you see the graph. In this case, I'm going to have just one node, so I'm done with nodes. The next thing is I want to add the edges. So this is where we had edges. We don't have edges as functions. We had it after we've added the node. So in this case, there will always be a start and an end. So which means, for every node you have, or like the edges is node plus one for a simple graph. But then you could have conditional edges. But when you don't have conditional edges, because you always have a start that we go to, in this case now, the start we go to ask question. In fact, you know what? Let's empty what is inside here so that you get it. Okay, so a node will always have a start. So where should it go to after the start? I want it to go to this node. I mean, an edge we have a start. Go to this node. So after it's gone to that node, what else should it do? So it must go from this node to something else. If I have another node, then yes. In this case, I don't have another node, so it goes to end. So this is the graph itself, sort of. We're building the graph. Then, now that I'm done with the nodes and the edges, I'm going to compile the graph, and then I'm going to now, this I like to do, is optional. I will tell it to generate the visual layout of the graph, the visual representation of the graph. So it's going to do the graph. I'm going to call this simple AI graph. Okay. And then we need to invoke the graph. So this is all up to here. We've only compiled, we've not used it. So to use it, there are multiple ways. You can call it to stream, you can call it to invoke and just give you the answer. So I'm going to invoke the graph. So I'm going to invoke the graph. Yes. So I'm going to say, okay, you know, in our session, I have this, sorry, in this session, yeah. I've got a user, task, and response, right? So all of these are available throughout the session, throughout the graph. So I'm going to say user, I'm passing it Michael Olafusi. Task is, now I pass it a question. Then response is what happens when it triggers, as it goes through the notes, it starts, it triggers the ask question. When this triggers, it will get the username and the task that I've passed here in this invoke. Then the LLM will respond to the question, and that response is what is going to return. It will print it so that we can see it here. Then it will return it. And then I can use it for something else. But let's run this. So that I also like to put a dummy variable to just make it possible for me to do a breakpoint. So we can evaluate all the debug variables. So I'm going to run this. Can see something happening that I don't want, that is not proper. It's not running it underneath my virtual environment. So that we can fix later anyway. So see, it says if we look at all the artifacts of the session, you'll see there's a start at the end. It has generated the graph. Where is it? See? It says this is a simple graph where anyway. It just has one node, start, ask, question, end. If I go back to the debug, run and debug. You see many other things, but let me just go back straight here and we look at what the output is. This is the response that we printed. So it says Canada has the largest number of lakes. Now here's the interesting thing. I want to switch this out. So I want to put a different, so I'm going to exit out of here. I'm going to pick, let's pick DeepSeek. So I'm going to pick DeepSeek, Llama, run, DeepSeek. So I think these are, let me see, this DeepSeek is 8 billion parameter one. This Llama is 4 billion parameter. This one is 7 billion parameter. Anyway, it's done. So let's go check it out. Let's test it. I'm going to paste here that I'm switching the model to DeepSeek. So this is the advantage of LangChain. The fact that I have, for whatsoever reason, either for optimization or for me toggling between something cheap and expensive, you know. So I'm going to stop this. Anyways, at the end, there's nothing more to do. and I run the debug again, and then we will see what will output here so that we get to see what answer DeepSeek gives, and we can compare with what we got with Olama, with Llama 3. Okay, and it tells you number of tokens too. I think somewhere here. So this one is, oh, this one came with a very long response. It tells us token. Yeah, 37 tokens, input tokens, 25 output, 62 tokens used in total. A token is about 4 characters, if you are using text input. So this one is using a lot more token, output token 646. And why did it take so much text to answer which country has the world, which country has the largest number of lakes? So I need to figure out, it is thinking. So it's thinking through the answers. But anyway, we don't have time to read through its thought process. All right, now you've gotten it. Let's just bring in chat, GPT into the picture, right? So I'm going to go here to the LLM, comment this out. In fact, let's first shift down to copy it down, comment this out, use instead of Olama, I'm going to use chat GPT, OpenAI. Okay, so it means I want to use OpenAI and I want to use a cheap model. Let's pick GPT-4 mini. Or let's pick GPT-4 anyway. It's not cheap, but I don't think I should be using so much tokens in this example. So I'm going to put this here. And then I'm going to complete this one and run. Okay. So you see, so this is the advantage of LangChain, the fact that I can swap things out. So now that you've gotten the basics, right? Let's go to, by the way, I think I can begin to change the meeting settings very soon. I don't think anybody wanting to hijack will still be here right now. They will have left and they'll be tired. They will go look for a better target. So I will soon change it, but let's start with the most important reason you are all here, the reasoning agent, right? So let me commit this one so that you can access the code for those who are following on. So done with the simple AI agents. So all of what we've done, you should be able to now access here. So did I sync? If I refresh this, so yes. So everything I've done, you should see here now, right? So we're making progress. I'm going to go back here. We'll create another. So this will be the daycare agent, daycare research agent. His name is long. Anyway, .py. So I'm going to be a bit faster here so that we can focus more on the part that is probably the interesting thing. You've gotten the concept of the flow. So this one we're going to do will be reasoning agent. What do I mean? The one we just finished is this. Just go one. In fact, has had just one step. Went from start step one to end. So we want to build one that will be this. It will be able to reason. So it will go. The LLM can pick a tool, go back here, reason, oh, do I have the right answer? If I don't have the right answer, I go back, pick another tool, or do something else. Then when I think I have the right answer, I end the session. So that's the one we want to build now. Okay. Great. So I'm going to, by now you are familiar with the key things. So I'm going to dump all the things I'm importing first of all. So I will dump all the libraries I need. Okay, so by now you understand why I need this and this. Anyway, you can read up on the ones that you don't, or I can talk about this one we already know. These are exactly what we had here. See? So these are the same thing here. Okay. So I brought in additional ones. I want to be able to access the CSV inputs so that the agent will pick this one by one, research, give me an output. So I need a CSV library. Then I'm going to pass it human message. I'm not going to chat, but I'm going to, when it is reading from here, I will tell it to simulate as if it is a human being that is typing and saying, I want to take care of this. So uh, that's why I'm going to wrap that in human message. Then there's AI message. AI message is the AI has come back with a response. Then there's system message. System message is mostly used for system prompt. So I'm going to say, okay, you have this persona. I'm giving it some prompt engineering to set the baseline. And so I can say, act like a crazy agent. All those things are things that will come on that system message anyway. Then I'm also going to, in this case, the simple one we did, we used a typed dic. A typed the agent, the session was a typed dictionary. So in this case, we're going to use something more complex, something that's going to keep context, save message. The same way when you chat with ChatGPT, you mention, my name is Michael, I'm interested in blah, blah, blah. And then you add type many things after. It keeps all those history. And if you ask something else and say, oh, what's my name? You will remember that, 6 chats ago, you said your name was Michael. So uh, that's this. This is already abstracting all of that for us, so I need it. Then I want to save, in case, what if I want to save the session, maybe into a DB, but for now, we're not going to save it into DB. We'll save it on RAM, right? So that we can, I don't know. In this case, we're not going to use it somewhere else, but in some cases, you might want to hand over to another session, another agent, and you want to pass all of that memory data to the other agent. So in this case, we are not going to do that. Looking at time, you know what? Let's just go on and build every other thing at this ones for now. Skip this. This is for conditional edges. If you want to say, oh, if you are not seeing any tool to use, just hand. So this one for now, I could even delete it. I might not use it. You know what? Let's just leave it. But I don't think I will use it in this example. So Pydantic is, I don't know if you're familiar with Pydantic, is a way to have like strict typing, within just like the way to convert JavaScript to TypeScript. So this is the equivalent of you now using Python as TypeScript sort of. And I'm going to use Google search. So that's why I'm bringing this. So like I told you, almost all the big vendors have an integration with LangChain. Google has created their own search API. So I'm going to need it to search online about the daycares and get information that are real time, are current, grounded in what's right now. Operator and anyway, these ones are easy to understand. So I'm going to move on. And if you don't understand, if you search online, you easily find it. So I'm going to use LLM ChatGPT 4 Mini, okay, because I want to conserve on price. How do I know the prices? So I think I have a page already where all the prices are. So if you go online and you search, you know what? You can search that by yourself. I have the page open, but now I have so many things open. Okay, this is it. So if you go here, you see all the prices. The first API agent I built, I spent maybe like more than I should. I think I spent maybe $70, and I could have spent less than a tenth of it because I wasn't needing to reason. But I was using an expensive one. So anyway, the one I'm using is this one. It's cheap and it's recent. So and it's good for what I want anyway. I'm setting temperature 0 so that it's not going to hallucinate. Like I'm telling it to be as factual as possible. Use whatever info I give it. Don't try to create new things for me. So I'm going to set up the agent itself. So I'm going to copy my code. So I want the agent to have a persona. I want it to, so see. So I'm going to set up the agent as a Pydantic class, almost like a data class. So the agent will have a name. I'm calling it Olafusi Daycare Researcher. And if you don't know about Pydantic, just search about Pydantic. So these are things you can find in documentation. You could give a property, the property type, field, put a default value, put a description. So for the name and the persona, I am putting a default value and say, oh, in this case, I like to be detailed. So I want the agent to factor in that, you're a detail-oriented person and I love diversity. I'm from a different continent, and so I'll prefer daycare that there's diversity. So I just added that there. So see. Then these other ones are things that will be dynamic. It's going to get location from the input CSV. It's going to get daycare websites from the input CSV. Then it's going to go online and research and get me reviews, price, and summary. So if I go back to the agent itself, you see that that's what I've done. I've created all those fields so that way I can condition the output of the agent to align with this structure. So that's why I'm doing this. So I'm like saying the LLM, this LLM, I'm binding it to a structure. Let's see. Let me show you how to bind it. You know what? You will see it eventually so that I don't say too many things that let's build it gradually. But this is me now customizing the LLM that I'm using and tell it that it should have this kind of personality. It should have a name, a persona, and it should always interact with these defined fields of data. Some of it to be input, some of it to be output that I'm expecting from it. I hope that is clear. So now that I've done that, remember what I said that we always need a state, a node, and we need edges. There will always be at least 2 edges or 3 edges. So I'm going to start with the states. So in this case, I'm going to, like I told us, that we're going to use something more sophisticated that can keep context, that can keep history of messages. And so I'm going to use message state. So I'm going to paste the code for the states. So now I'm no longer using a type dictionary. Before we used a typed dictionary, use a type dictionary for our states. I'm using something else this time around. And it will keep adding to the context. So I told you that every new chat history, every new interaction, when you go and you search and you don't get an answer, still keep the answer you have right now, then go back and search again, keep the context so that you can have all the details you need to give me the best output. So that's why I said this context should be always an annotation. Whenever you say context is equal to something, it will not override the previous entries. It will just annotate, like add to it. So that's the use of that. Then I'm going to set up my Google search. Okay. So for the Google search, you need some APIs. If I go to the example, you need to get all these API keys. So you can get that yourself. They're not difficult. You get it from Google. So I'm going to just set up the search tool. So a tool is any additional capability you give to your agent. In this case, I'm giving the agent the ability to go online and search on Google. So that's something that the agent does not have by itself. At least the one I'm using, the LLM does not have that. The LLM I'm using cannot go online and search by itself. So I'm the one that is giving it that tool. If I tell it to be able to go to my email and search through my emails, I will have to create a tool for that. So that's what we mean. We're giving it additional capability. That's what makes AI agents interesting. You give something that is intelligent, but it doesn't know too much about your interests. You're not giving it tools that are important to you and telling it to do things that you would have done yourself. Okay. So I'm going to also, I want the AI agent, right, to craft out a search that what it will type in Google search. I want it to craft it out in a way that will be relevant for me. So I'm also going to use a Pydantic. That's the usefulness. Or anytime you want to make what's important to you be respected in how the AI agent outputs things, it's just best to use the pedantic model to capture it. So I'm going to create a pedantic model to limit how, at least to make it send an optimized search query when it's Googling online. It will put in the keywords that I want, and it will do it in a way that it will be useful for my agent to use. Like the output will be better aligned with what I want. So that's why I'm creating these. It doesn't have much. It's just to say that it's a string. So I want you to optimize the string. I'll show you how we do that. So I'm going to also, the responses, right? Remember what I said, that here I have put the default value. If I make this a commercial agent, then I'll make it possible that you can override the default with your own persona and your name, right? This location, daycare, and website is going to come from the CSV. So we know that, okay? But these are supposed to be the output I'm expecting from the LLM. Okay, so I want the LLM to also understand that at this stage, when I'm going to need this output, that particular node that is going to take all the search result and reason on it and decide whether it has all this information should be aware of this structure of the output that I want. Okay, so to make that happen, guess again what I'm going to use: a pedantic model. So I'm going to say I'm going to structure the response to at least have this structure, so that I can say maybe output it to me as a JSON or something else where I can programmatically pick from, not just modeled up in sentences, right? So that, and then I'm going to now bind I'm going to say that the LLM should be aware of the tool. Okay, so I'm going to bind the tool, which in this case is the search tool, to the LLM. I'm typing this because this is important. You must remember that this is what makes an AI agent better than that. This was special about AI agent. The fact that you give it tools that you have programmed yourself, not what is default there in the base foundational models. So remember, we have the LLM already here. So what I'm saying is that I'm going to say I'm going to have an LLM that now has additional capabilities with tools. You can call it whatever you want, but this is what I'm choosing to call it. So now I'm calling the LLM that I have already defined here, and I'm going to say I want to bind. So bind with bind tools. So, and tools are always coded as a function. So this is essentially a function or a method. So I'm going to bind it with a list of all the tools I have. In this case, I have just one tool. So I'm going to bind it with just this. If I have more tools, I could even create another tool if we want. I could say, okay, I'm going to create a repeat 5x repeat 5 times, and maybe this is the agent I want. Repeat x times. And I tell you that you should expect an x that is an integer. And I say, you know what, it should just repeat maybe something else, another string. Text in string. So, and then I'll just say should repeat whatever I was passing as text the number of times, and then I'll come here. Now I can come here and add it as a tool. I'm just showing you that you can create functions and bring them in here as tool. But this is useless for what we want to do. This Google search is going to be enough for what I want. So that's why I'm not going to do additional tools. Okay, so now that that is done, I'm going to create the prompt. So you have to be good at prompt engineering. In case you've been seeing this online and you've never really bothered about it, it's the bedrock of proper AI agent building and even use. Every aspect of AI, generative AI is prompt engineering is important. So I'm going to just copy the prompt I already have. So we are going to use two prompts for each node. We have two nodes in our case. The node that is going to come up with the search query. So there's a node that will output the search query that we will send back to Google to go and get real-time information that we want about the reviews, about the price, about the description of the daycare. So this will be that one, the search instructions we want it to have, search instructions. Then I'm going to do another one that will take the output of the Google search and reason through it and get me the information that I need, the output I want, which is in our case, we want to review, price, summary, structured as a dictionary so that I can be able to programmatically access it and put it in a CSV. Okay, so this is another prompt. So you have to be good at prompt engineering. I hope you have heard of zero-shot prompt, one-shot prompt, multi-shot prompts. Like the more examples you give your prompt, that's what we call short. When you don't give an example, then zero-shot. When you give one example, it's one-shot prompt. And when you give more than one example, then it's multiple shot prompt. Okay, so that part is done. Well, we're almost there. Oh, but it's already 9:02. But just let's stop somewhere. Let's finish. So sorry that it's going out both time, but I hope you're getting it. Let me also at this point change the meeting settings so that, or maybe I'll change it at the end. Because I never can. Maybe one of them has been listening and has been in hibernation mode and is just monitoring what I say. So let's finish. So at least if I need to cut anything out of the video, I'm not cutting out the important part. So great. Remember what I said, that we have to create, let me just go here. We have to create states. We've done that. We have to create nodes. We've not yet created node, but we've created everything we need for our node. So I need to go here and now create a node. So I'm going to create a search node. We're going to use two nodes. One node that we go online and search. Okay. So search node, this is going to go online and search, and then search with her. Then output. So after it searches, it's going to output into the context that is available for our entire graph, whatever it finds, from Google online search, so that another node will take that, reason on it, and come up with the output I'm looking for. So that means I need to create one more node. So in this case, we did a web search node. We'll do the reasoning node, create the reasoning to okay. It's not the best way to write it, but the message is obvious. So I'm going to grab the function from where I have it. So we're going to create the reasoning node. And as you know, I'm going to commit this and sync so you can get it in that publicly available repo that I've created. So we are going to create a reasoning node that will get the context which we have already enriched. We have enriched the context with our search output. So it's going to get the context. Okay. So then it's going to do a couple of things. Let me add a couple of things it's going to do. So when it gets the context, it's going to now create a system message. Okay. This is our system message anyway, but it's going to take our search instruction. Our classification instruction. And you will see we have some dynamic values there. So it's going to fill it with the information from the the CSV so that it will be customized to whichever daycare we are processing currently. So it will put the persona, put the location. Let me close this part. Put the agent location. Put the location, daycare, and all of that information and the context that we have gotten from these other one. Where did we get it? Oh, I pasted this in the wrong place. Yeah, it's it. Yeah, good. So it will get the context which we already have enriched here, and then it will now send to the LLM to now, do all of these prompts that we have said and give us an output, return the output as message. So you see that we are putting output of this other node into the context. Whereas the final output that is going to go to the CSV, I'm putting it in the message. Why? So the reason is I have creatively set up my context to always be adding more information. So every time we run a search, it keeps adding into the context so that I will have as rich a context as possible. Whereas my message, I just want it as a list of outputs that I can pick from it, the summary, the price, and the reviews. Okay, so it will just be like a dictionary, a list of dictionaries eventually. So that's the reason why I didn't output into the context, because I don't need the context for my output. I only just need this last part of the reasoning to give me an output that I can use. Okay. So now that that is clear, what we are left with is when we don't get the answer that we want, right? How do we let it know we've not gotten the answer we want? You should go back and search again. You should, reason on and as many iteration as it needs to do to get us the answer we want. So we're going to create a function to do that. It's called conditional hedge logic. So that's what we create like a feedback loop. Okay. So I'm going to say that if the summary is empty, I could say many other things, but I'll tell you why I picked if the summary is empty. Because when I tested, I found out that it was always getting reviews. It was always getting, but was never always getting summary. So I'm like, okay, if you couldn't figure out a summary from this your current, search online and looking through the result, then go back and search again. Add what you find, keep it in a context, go back and search, get new set of information, put it into the context, until you're able to find, answer that fills into the summary before you will now end this instance of the run. So now that we've created that logic, I'm going to now do the real graph. So all of this was simply to create, let me go back here. We've only created states and the things to help us to structure the LLM to give us output in the way we want. So that would be the pedantic models, and then nodes and edges. So that's what we've done so far. So we need to create the graph itself. And like I told us, for Python programming best practices, we're going to put it in a main. Okay. So I'm going to copy the entire code and walk yours through, because the main part is not long. It is the long part of it is the reading the CSV, creating an output file. So I don't want to stress us. So I want to be able to let you know what we need for sure. So let's delete what we don't need. Okay, great. So as usual, you initialize a builder. So you're going to say, okay, a graph builder. I'm going to use these states that I've created. If you remember, we created the states here. We call the state online search. So there will always be a state that will be persistent throughout the session. There can be more than one state, but that's complex now. So you can have multiple states and states, you want a private state and a public state. But in this case, we are not doing that. So I had nodes. In this case, we have two nodes. Remember that I said nodes are functions. So in our case, online search, research, web search, research outputs. If I go here, this is the first node, which does the web search, gets the output from Google search, puts it into the context. then the research output, reasons on that output, and gets us the message that we have already used prompt engineering to tell it to give us in a format that will be usable for us, reviews, price, and summary. Okay, so that's this part. So these are the two nodes. And remember, I told us there will always be an edge, a start. So start, after start, go to the online search node. So this is the edge that is like start to online search. Then when you do the online search, go to research node. Now, this is the interesting part. When you do the research node, don't just go to end. Use the conditional hedge to know whether you should go back and do another online search or you should just give me the output. So this is that one, and I'll say, okay, check. Were you able to populate the agent summary? If not, go back to the online search. Otherwise, end and give me the output you've got. And that end and give me the output you've got. I'll show you how we are being able to, and now passing that into the CSV. So that these are my edges, right? Then I'm now saying I want to be able to save each session in memory, like be able to maybe eventually write it to a MySQL DB or a PostgreDB or some DB eventually. But for now, I'm just saving it in memory. Okay, so I initialize this. So there's nothing. This is like something you just do copy paste if you want to if you want to save in memory. If you want to save in DB, then you go and find the version that will be say saving in DB for you. Okay, then you already know about this, right? So I'm going to call this daycare AI agent, daycare research. It's long, but okay, so it's going to draw the graph. We're going to see what it looks like the same way we were able to see which graph was that. This one. We'll see if truly what we've configured for the graph, the logic is flowing the way we intend it to. Okay. So this, and then we are supposed to invoke it, right? So this is where things are now interesting. So the invoking is an iteration. I'm telling it to run through my input CSV and go record by record and then invoke it for each record. Okay, so this is check if I have an output CSV. If I don't have, create an output CSV. Then create these fields, these columns in the output CSV. Okay, so this one is not difficult. This one is just to check if I don't have an output CSV, create. So now run through the input CSV. Okay, and then go line by line, right? If there is no processed, so in this case, there's no processed. So I want it to also keep track of what it has processed in case if there is a power outage. Just kidding. But in case if something happened and I needed to pause and I needed to resume from where I paused, so it doesn't go starting all over again and my tokens get used up and OpenAI keeps billing me like crazy. It was actually because OpenAI was billing me like crazy on the first one. My money was just going quick that I like, okay, I better put a logic to keep track of what is done instead of it doing everything all over. So it checks for, is there a process column? If there's no process column in that, it creates a process column. Then it appends 0 to everybody. Then as it begins to work on each record at a time, then it's going to add 1 to, so that way I know which columns it has worked for. Then this is where it does the invoking. So you can see it's going to initialize the agent and say, okay, agent location is equal to the first data, first field, in the row I'm on. Okay, so for each row, you can see for each row. So get the location, daycare website. For now, we don't know the reviews and the price and summary because this is the inputs right now. So initialize my session thread. So create the graph that we have created. Give it a memory storage area of 1. Okay. Then run the graph. Like update the graph states. Update it by filling this information we now have. Okay. So when you fill that information, now imitate me as a human being that is interacting with it and say, hi, here are the details of the daycare that I want you to work on. So I say, okay, imitate as if I'm maybe as human beings interacting with this agent, and it's like, hello, here are the daycare details, and then it's putting in all those details as we now already have, right? And then based on that new updated session, updated states, a state that now has the details of the daycare and all of these, invoke the LLM process, like the graph should now run from start to end. So it will run, and then let's put a breakpoint. Well, let's put a breakpoint. Yeah, just before we write the answer back. Well, you know what? Let's put it after we write the answer. Yeah, let's put it here before we go back to update the input file to say we've processed that one. So if I run it, let's run it, and let's make this debug area wider so we can see the output. For some reason, this thing is not picking my VM virtual environment, but no worries, as long as I don't get an error. Okay, so it's already searching online, searching, it's gone through Toronto, it's if I go now to if I scroll, I should be able to see the output somewhere. Let's see. Summary, can you see? So the message, which is where we are putting the output, review, it has put the review, it has put price, summary. So if I go back here and I check the output CSV, I should be able to see that information. So it has created an output CSV. It has said for A&A daycare with this website. A&A daycare, let's see if we can format this into wrap text. On Mac is option Z. Okay, I'm using cursor. So anyway, let's just scroll. So it has put in these values, A and A daycare has this, and then this is the next one. This is the price related. It offers competitive pricing, but specific details of tuition rates are not readily available. Is advised that family contact the daycare, blah, 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 blah. Additional daycare subsidies, if you are a family in need, blah, blah. Then daycare is well regarded in Toronto. So it's done a good job, actually. Parents have reported positive experiences, particularly in terms of child happiness and engagement. If A&A staff are in this call, they should be happy. For enrollment, it's recommended to inquire directly for the registration process and any potential wait list. Some parents have mentioned securing spots. So this one is a good daycare. They don't have terrible wait list stuff. If I take off the breakpoint and I run everything to the end so that you can compare the outputs that we get, daycare by daycare, you'll be amazed, So let me change the meeting settings so you can be able to ask questions since, at this point, I don't think the people who are trying to hijack the session are still here. So let me go here, settings, meeting options. So I'm going to allow people to be able to meeting chat on, apply. Okay, do you have any questions? Unfortunately, for those of us raising our hands now, we are still under siege from some people. Can you try to use the chat? Okay, so it's done. Let's examine the output. But you can see that this is not this is even the company, the daycare we had it right in the call, right? So I wasn't sure where the noise I was hearing was coming from. So let's open it. I'm going to open in Excel so that it's easier to read. I hope I'm opening the live one. Yeah, I'm opening the live demo. Then let me put this in. I'm going to commit this code done with the demo. Oh, sorry. Oh yeah, can I have the GitHub link? Yes. That's a good ask. Done with the demo and output. Okay. So if you go on the GitHub, GitHub is this. I scroll over here. So this is it. This is the repo, and you'll see everything we've done. The code, the GitHub repo is here. I have to look for how to cut out, the profanity that guy mentioned in the call. I have to remember to do that before posting the video. Okay, any other questions? Sorry, I'm not going to be able to allow us to unmute. We are still under siege, so please, can you, you know, uh, put your questions in the chat? Yeah, it's a lot of information. That reminds me, where will you find the recording? When we are done, the recording is going to, I would say, make sure you join the community page, join the community so that you are in the loop of all events we have. So that's one. Then the recordings, did I put it here? The recordings are always going to be on YouTube, MHS Analytics. I can get our YouTube link. The guy is bombarding the chat now. Okay, YouTube link here. So I'll have to close the chat. Go to meeting options. Thank God I know how to do this. Imagine I don't know how to do this. Okay, great. So I don't know if there's a way to delete what someone has written. Apologies for all the profanity is put again in the chat. But by now you should be able to see in the YouTube link. The YouTube link. So I think we'll head it here. Unfortunately, all the ways we could have interacted, you know, these people have blocked them. If I turn on audio, they come off mute. If I turn on chat, they come off, they start bombarding the chat with. Well, I hope you enjoyed the session. I hope you learned something new, and I hope you're going to at least. I know it's a lot of information, but see, we built two agents in the. Oh, let me show you the graph. This is the graph. Can you see? So it shows that, this is a reasoning agent. It goes an online search. It does research. If it thinks it needs more online research, it goes back to do online research. Then when it thinks it's got all what it needs, then it ends the session. So thank you very, very much. Sorry, apologies that we had a degraded interactive session today. It's not the usual way. I think that's what the disadvantage of popularity. I think the session is getting popular, and we unfortunately attracted the wrong set of audience amongst us. But I'm glad that a lot of you stayed till now, and I hope you got value from it. If you have questions, you can use let me not say now before the guys go back there and also use that. But you know what? Thank you very, very much. So have a great rest of the evening, and you can always try to reach me. Just go on LinkedIn, search me out. Um, at least LinkedIn, if somebody sends me a message that is not the right thing, I can delete. There's no way someone can bombard my contact. It's only me they can directly send something to. So just go on LinkedIn, type my name or type Olafusi Michael. I think even if you type Olafusi, I will come up. So connect with me, and if you have any questions, I try to answer. So thank you very, very much. Have a wonderful rest of the night and a good week ahead, and happy Easter ahead to to be a restful weekend ahead. It's like 4 days from now anyway. So bye. Cheers.